Momentum is a force or speed of movement. It can also be called linear momentum. In physics, momentum equals p. Newton's second law states that the rate of change of momentum of a body is equal to the net force applied to it. So, momentum divided by time equals a force. So, if you have a car of mass 1,100 kilograms and it moves at a speed of 24 meters per second, what is the braking force needed to bring a car to a halt in 2 seconds? Mass times velocity over time is another way of saying momentum divided by time because mass times velocity equals momentum. Since we are looking for the force, we will use the equation force equals mass times the change in velocity over the change in time. So 1,100, the mass, times 24, the velocity, divided by 2, the time, is the same as saying 1,100 times 12, which gives you your force of 13,200 newtons. Let's try another one. What is the force on a 0.025 kilogram egg from a bed sheet as the egg hits a sheet at 4.0 meters per second and takes 0.2 seconds to stop? The same equation will be used again of force equals mass times the change in velocity divided by the change in time. So, force equals 0.025, the mass, times 4, the velocity, divided by 0.2, the time, to equal the force of the egg hitting the sheet of 0.5 newtons. Let's try one more. A 1,200 kilogram car is brought from 25 meters per second to 10 meters per second over a time period of 5 seconds. Determine the force experienced by the car. Because force equals mass times the change in velocity over the change in time, we have to be mindful of the initial and final velocities. So, force equals the mass, 1,200, times the change in velocity, or velocity initial, 25, minus velocity final, 10, all divided by the time of 5 seconds. All of this would get you your final force of 3,600 newtons per second.
Science guy. Bill Nye, the science guy. Bill Nye, the science guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Ping pong balls are great for ping pong, but they're not for bowling. Not enough momentum.
Oh, a scientist.
Bowling balls are about 3 kilograms. They're heavy enough, and we can get them moving fast enough so that they have enough momentum to knock down all the pins at once. That is, if we can hit it just right. Well, that was pretty good. But suppose we had a heavier ball, like 4 or 5 kilograms. Then it would have enough momentum to knock down every pin every time. Now, that would be cool.
Hey, Bill.
Huh?
Catch.
Oh.
And now, great moments in momentum.
Honey,
has been great moment in momentum. Bill Nye the Science Guy.
Now let's try a problem on impulse. Impulse equals force times time, or mass times change in velocity. What is the impulse of a 3 kilogram object accelerating from rest to 12 meters per second? Mass equals 3 kilograms. The initial velocity is 0, and the final velocity is 12. So, mass times initial velocity minus final velocity is 3 times 0 minus 12, or 36 meters per second.